My name is Carlos, and I work at CCV, working mostly Julia for the last several months. So I think this is going to be useful for anyone who writes code, not just in Julia. Writing reusable code may have a different flavor depending on the programming language that you're writing the code in. But the ideas, I think, extrapolate pretty nicely. So to motivate the talk and workshop, consider the following use case. You work on a research project that requires some computation. Right? You write your code, you test it, good for you, and it just works, right? That's great. So you decide your code is general enough that it could be useful for solving related problems, probably by other researchers within your research community. So you decide to tell others about it, perhaps at a conference, right? Other people heard the message and they decide that your code would be useful for them, right? So now we're getting visibility. That's awesome, right? They take the code, they try to use it, and the horror, it doesn't work, right? For us as developers, that's not great. Right? And if they're lucky enough, it may work, but it doesn't work as we were expecting the code to work. What's happening? So this is a problem that happens to many people in science who write computational code. And the problem is that often the code we wrote is not reusable. It works for us, works on my machine, but I pass it to my collaborator and it doesn't work. That means that the code is not reusable. And if it works and they don't obtain the same results as we are kind of like suggesting in a paper, for example, that means that the code is not consistent. So reusable code is consistent. It doesn't depend on the computer on which we're running the code. And it yields correct results. So it's correct. So those are two attributes of reusable code, among others. For example, easy to use, easy to install, and so on. Easy to read, for example, easy to maintain, and so on. But for the talk today, we're going to focus on writing code that leverages tooling that's in place for distribution and installation. And we're going to be very confident that our code is consistent and it's correct. Okay, so that's what the talk is and workshop today is about. And we're going to be doing so within the Julia ecosystem. Okay, we're going to be leverage tooling to write reusable code in Julia. Okay, and I had suggested earlier that we should have a few things in place before we get going. We're going to need the de facto editor for Julia code, DSCoV. We're going to need Git. Hopefully everybody here is familiar with Git. And if you're not, don't worry about it. There's tooling within DSCoV that allows us to leverage Git without having to write anything on the command line. And we're going to need Julia itself. Right. So let's start kind of like, by the way, feel free to interrupt at any time with comments, questions. We'll try to make these workshops as interactive as possible. Okay. So here's a definition for us of reusable code. Code that is easy to distribute and use correctly and consistently. And to write reusable code in Julia, before we get started, we need to understand how to manage dependencies. Is that a new buzzword for anyone here? dependency. What is that, right? So we need to define dependency and see how to manage environments within it. A dependency is simply code other people wrote that we're using for our project. That's pretty much what a dependency is. And it's typically code that's reusable, right? So it's versionized, it's relatively well documented, and so on. So let's practice a little bit, adding some dependencies to our base Julia installation. Let's go to the terminal and do that. So here I have a terminal. Let me make this text a little bit bigger. And I'm going to just launch Julia here. Let's see if my computer, yeah, there we go. It's giving me some feedback here about something. Can I get the prompt? There we go. So in Julia, you have this Julia mode for running commands. But if you press the close bracket key, this key, you go into package mode or the package manager within Julia. So to see the code that we have installed, dependencies, packages that we install into our base Julia instance, we just type the status command and run it. And as you can see, I have one package installed here. You may have other packages. To remove a package, you use the remove or the RM command. So I'm going to remove this, my package. And we check the status again. There's a short version of the commands, ST. And I can see now that I have no packages. Okay. To add a package, we use the add command and the name of the package. If the package is already in a registry, that's good because that facilitates installing packages. For example, we can install the example package with add example. Not really sure why my computer is a little bit sluggish here, but as you can see, Julia is giving us some feedback that it's grabbing some repo from some URL. It's updating some registries. It's resolving stuff. And then it's saying that we have example version 0.53 installed. Let's check the status again. And we can see that we have indeed the example package added, and we can use it now. So this is something that we would like to do with our code, that someone else can just say add name of the package or perhaps a link to a repository somewhere and just get it right away. Okay. So this is how we manage dependencies in Julia. Any questions so far? It's really this easy. That's one of the many features I like about the Julia programming language. Yes.
So this add package feature, is it like comparable to other languages like package management, things like PIP or
yes,
yeah.
Exactly. Yep. That's how we do it. In Julia, the package manager is built into the language, which is very nice. Right? We don't have to, like, if we launch Python, for example, if there's people here familiar with the Python ecosystem, if you launch an instance of Python and you don't have the package already installed, you're in trouble. You have to exit, install, and then come back in. Here in Julia, we just add it and it's ready to go. We can use it right away. Any other questions? Very good question.
Actually, I do have a quick one.
Yeah, we have one in the chat. Go ahead.
Oh, no, please. I'll let the chat go first.
No, I mean on Zoom, not the chat.
Okay. Yes. All right. When we speak about registries, I'm assuming it's similar to the setup like with pip or with Conda. Are there any preferred registries? I do see that it looks like it's going to a general.toml file, and maybe that can be edited with preferred registries.
Very good question. Yes, this is something that a registry is kind of like a table somewhere that lists package names and a link to a repository where the files are, pretty much. Now in Julia, we have many registries, but the official Julia registry is where you would probably register your package for maximum exposure. If you are within a scientific community and they prefer to host their packages, because there's many researchers working on associated problems, they may choose to create a particular registry and have their packages hosted in a separate registry. But for the most part, again, for maximum exposure, you would like to register your packages in the official Julia registry. Yeah. So indeed, it's similar to PyPy, Conda, Forge, and so on. Yeah. Very good question. Any more questions? Yeah.
So when you add this example package here, is that being added to the global installation or the global environment?
Yeah, exactly.
So I'm familiar with virtual environments in Python. Is it easy to make a separate environment that has nothing to do with the global installation?
Absolutely. Yes, that is possible. And this is exactly what we're going to do next when we're gonna make our code reusable. Yeah. Very good question. Yes. Yes. Another question was that does the package manager handle versioning and versions of packages? And yes, it does. The package manager also keeps track of this metadata. The version, as you can see here, when we added the example package, says version 0.53. That is probably the latest version that's available. And we have a record on file about the versions that we have installed, either in the base Julia or a particular environment that we're going to be setting up later. Yes. A folder version? Yes, we can do by specifying the version. There's a directive. I think you say @, but when you do package name, and then the version number, you can install specific versions as well. Yes. If you don't specify any version, then you just get the latest available version of the package. Yeah, indeed. Very good questions. Yeah, I'm loving this already. Any further questions? No? Okay. So let me go back to my little README. And I'm just kind of like showing you, if you go back to the README later, kind of like what we're doing over here. So we can add dependencies, remove dependencies, check the status of our Julia base or environment that we're going to be doing in a few moments. Now, let's make a package. What is a package? That may be a new word for many people. As I say here, a package is code with structure that leverages available tooling for efficient distribution and use. That's pretty much what a package is. Right? It's just code that conforms to tooling that's in place for people to grab the code, install it. Okay? Nothing fancy about, there's dependencies and pack. Once we understand everything, we got to appreciate vocabulary because, it facilitates communication, but we need to get these words out of the way, right? So we can really understand what we're doing. So this structure, this special structure that we need to add to our code, we could do by hand, of course. But there's tooling already to do this kind of task. And we're going to leverage it today. We're going to show you how to do that. Okay? There's a couple of options, right? To kind of like inherit structure and then conform our code to the structure. The simplest way is probably to just use the generate keyword in the package manager. This PKG in Julia refers to an internal module with functions that the package manager kind of like wraps to kind of like call them as a command line tool, right? So generate is one way to just get a quick and dirty, bare bones structure for code that's going to be packaged. And this is what we're going to be focusing on today. But there's other alternatives. If you want more stuff added, more structure, depending on what you're going to do with your package, you can use the PKG templates Julia package. It'll prompt you for things like a README. Do you want to add a license? Do you want to add documentation? Do you want to add a test suite? Do you want to add CI? Like stuff that you would have the code do in your repo beyond what's in the code. For example, generate a container, kind of like a thing that other people can just grab and run with your code embedded into, for example, and more. Code coverage, right? If you are into that kind of thing, and so on and so forth, okay? Or you could just clone a repo that already has the structure that you're looking for, right? And then just fill in the details. I am providing here two sample repos. There's the example.jl package. If you go here, let's go there, why not? Just to show you a little bit. Let me zoom out. You can see the repo. And here's an example of a package. We see some files. We see these docs files. We see this SRC folder. We see this test folder and a whole bunch of other files. The license, the project, that TOML, which we're going to look at in a little bit. And there's a README over here as well. You can just clone this one and then put your code in there. Rename stuff, and you're ready to go. So we have options, depending on what fits your likes the most, okay? So coming back to our README, let's now create a package, right? It's kind of like a toy little package. And like I said, we're going to use this generate command within the Julia package manager. So let me go back to my terminal here and navigate to a location where I want this package to live, right, within my computer. So I can go back and go into the shell mode in Julia and see where I am with pwd, just a regular command. And I see that I am in my documents folder. Yeah. I go out of the package manager with backspace, and then with the semicolon, I go into shell mode. Okay? And now I have access to shell command. pwd, ls, I can make directories, move stuff around, delete stuff, and I'm still within Julia. So I can go back with backspace into Julia mode and keep working on Julia. So now that I know I am in my documents, I'm going to go back to the package manager with close bracket and use the generate command. And I'm going to call it my package. My package using camel case here. And press enter. And it says that I already have something like this because, you know, I was playing around with it. So I'm just going to add 1, 2, 3 here to get something new. And there we go. It says that it generated a project called my package 1, 2, 3. Let's go to that folder. Let's see. Go back to shell mode, and I'm going to cd into my package 1, 2, 3. And do ls. You see what's in there. And it seems like there's a few things that were already done for us. So first of all, the folder was created with the name that we provided to generate. And within the folder, we have this project.toml file. Remember, we saw it before in the sample repos. And the SRC, this is a folder. Does SRC have stuff in it? Let's see, ls src. Indeed, there's stuff in there too. There is a mypackage.123.jl file. Because we're now going to be working with these files, let's go over to VS Code. Take a look at it. So let's do pwd. Okay, I don't know if I can launch VS Code from here, but I already have it opened. So I'm going to go over to here to VS Code, and I'm going to open a folder. I'm going to do open folder. Yeah. I can try it. Why not, right? Let's see, code. Can't spawn it. I mean, I would need to get out, but I don't want to have to get out and then come back. Because I have it over here, might as well do it this way. So documents, and I'm going to go to my package. 1, 2, 3. There we go. Select folder. And here we go. Here's the file browser on the left. And indeed, we see the project.toml file. Let's take a look at it. Zoom in so we can see it better. And we see some metadata that was generated already. We have a name, a unique universal identifier number, the author, because I already had this set up, and the version. Assuming that we're starting this package from scratch. Okay. And under the SRC folder, we have this my package 123.jl. If you've worked with Julia before, this is what they call a module, which is kind of like a thing for organizing your code, defining new namespaces and so on and so forth. Okay? And we have the greet function included. So if we were to run this, we're going to have this function available. Okay? So that's what generate did for. And it's up to us to add more features, right, to this basic structure. Okay? So let's do that. Let me go back to my README. And I'm going to go ahead and just copy this snippet. As you can see, I'm adding a dependency here with the using keyword and the package name. And if I want specific objects from that package, I can include it right here. So I don't have to prepend the name of the object when I use it later in my code. And I'm adding the feature, right? Fact, because I want to use this do math function from example. And what do math does is to add 5 to numbers. Very boring math, but you know, I'm a mathematician, so that's kind of like boring to me. They could have done something a little bit more interesting. But anyways, we're going to use this function because we're too lazy to write our own add 5 function, right? So we get it from the example package, okay? So I'm going to copy this and replace the contents of this my package 123.jl file, like so. Add a space because we don't know if we want to add more stuff later to this programmatically, and save it. Okay? Yes.
Like this alternate function declaration syntax. Would you mind talking a little bit about that? How Julia has to sort of change vectors.
Very good observation, Paul. Thank you. So for those who are new to the Julia ecosystem, here we have defined a function by just saying function name, arguments, equals, and the definition of the function. Right? This is a very convenient way of defining kind of like one-line function, right? If you have something more complex that probably reads data from somewhere, does some computation, writes results to file or something, or displays information to screen, you probably want to use the more standard way of defining functions by using the, how do you do this in Julia? I'm blanking right now. Is it function? Yeah, function. So you say function, function name, and then you have the end. You can delimit the scope of the function explicitly, and then put your code within the function. Yes. But this is a quick way of defining simple functions in Julia, which is very convenient. Yep. Thank you. Any questions about, we're not really here to discuss code, right? Or coding in Julia, but if you have any questions, by all means, feel free to ask. Okay. I'm gonna ask myself a question, now that we're in the weeds of the code. Yeah.
What's export fact?
Very good question. That's exactly what the question that I was gonna ask myself. Export here is making this function available after we invoke this module. So in Julia, if I were to say after installing this package, I were to say using my package 123, I can have access to fact immediately. So it's going to be brought into scope. And I won't have to say my package 123.fact to use it. So that's a nice feature of Julia. It brings it into scope once we import it, or we bring the module into scope. Into scope. Yep.
What's the syntax for if we want to like import or export multiple functions from that package? Is it just a comma or?
Yeah, you add a comma here, and then you add more stuff. Exactly. Yeah.
And if you don't do export, you would have to do like my package.
Yeah, you have to prepend it. Yeah. So Julia knows where to find this function.
You have like a lot of similar type things, but that do different things that you
Indeed.
see in like the scientific community, like one that does like this level of accuracy versus this, and then you have to use different codes. But
Absolutely, yes.
you might call it.
Right. It depends on the complexity of your code also, right? If you're grabbing stuff from different modules and different packages, you might want to be as explicit as possible so to let people know where these functions are coming, if they're not explicitly defined within the scope of the module, right? Very good point. Thank you. And I guess what else can we say about this very simple module? I guess that's pretty much it, right? Can't get simpler than this. All right, so let's see if our fact function works, right? We have to test stuff before we make a package, right?
What is the whole that is it doing integral math or floating point math?
We would need to go into the weeds of the do math function, right? We would need to go into the code and see what that's doing. I'm not really sure. I'm thinking it's probably just letting Julia handle that and kind of like cast to the most general type that allows for the operation. Yeah, if we don't specify it. Yeah. Great question. Okay, so can we test our code? So if you installed the Julia extension in VS Code, let me make sure that I did that. So we go to the extensions, installed, and I see Julia. So I have the Julia extension installed. It's a very nice extension for working with Julia. In particular, if it facilitates running code that you have displayed on your screen.
I just quickly looked it up and it says it just gives X a number. When you do math, it just gives the X a number and then it does the like addition of X plus 5.
Oh, you're talking about the do math function?
Yeah.
Okay.
So I don't know. I'm a little bit still confused about how those kind of like
The casting?
Like I know how like the int works, but I don't know how like the love int, like when it's like number.
Okay, yes, there's different types, number types in Julia. We can discuss those a little bit after, during the Q&A. Yeah.
No, but that's the answer. So I would just assume it only does it using
Yeah. Those details are taken care of for us, right? It's a flexible language, so that's another nice feature. If you have different types and the operation is allowable, it'll do it for you. Okay? So with the Julia extension, we can try to run this code right here. So I'm going to press Shift Enter. And as you can see here, a new terminal was launched. And we're ready to run this code. I guess it did run it. Let's see, do we have fact? It says that we have fact. So let's just try to run it. Was that? Oh, you have an error. What kind of error?
It says error, syntax, incomplete, premature end of input.
We would need to look at your specific file. Premature end of input, that could mean that you may have a missing close parentheses or something like that. We don't really know. Who else had problems running? You got a different error? Hey, error. Well, let's take a look at this thing. So do you have the Julia extension? Okay, and what happens when you executed Shift Enter? Yeah, from here. So activate this file and then press Shift Enter. You may be running something different. So if you want to run the whole thing, you can just copy everything. So do copy all and then paste it into Julia. And now paste it. Yes, there we go. That's what the VS Code Julia extension did for me, if I had it set up.
I think we have different keyboards.
Probably too, yes. But the default one is just Shift. So it grabs the full thing that I have here, the largest scope within my cursor, and sends it to a special property. Okay. But if that didn't work for you, just copy everything and paste it into Julia. Okay. Now let's see, is this working? Fact. And it's not working for me. I'm getting this undefined var error, do math, not defined, which is supposed to be coming from example. So this is a problem, right? Why is this happening? Why isn't Julia finding facts? I mean, do math from example. Let's see. Let's go to the package manager. As you can see, in my prompt here, let me make this a little bit bigger and show you. I have my package 1, 2, 3. What happens when you go into the package manager? Do you see my package or the name that you used before? Or do you see just V 1.9 something? Right. Okay, that's fine. Did it run for you? Fact, it didn't work. Did you get the same error? Did you get a different error? Okay. Oh, that's the same error that I just got. Well, not for fact, but for do math. Okay. So we have to do a little bit of debug before we get this thinking. Okay. In my case, the problem is that I don't have the example package in my scope. And that's why Julia is saying, I don't know where to find this do math function that you want me to use. So we need to tell Julia, grab do math from example. Okay, so this is where the managing environments it's gonna come into play. Let's do that. And again, you may see a different prompt here because I work in Julia a lot and I'm activating environments and stuff like that all the time. So I have my terminal to activate something if my environment has a project.toml file. So I'm gonna get out of it. Well, actually, I don't have to get out of it. I want to be in here, but let's get out. So we are all on the same spot. To get out, go to your base, Julia, you issue the activate command. So let's do that. And as you can see, I'm back to my base, Julia. Let me check the status here. I have example. See, I have it right there. Why did I need to grab it from there? Let's remove it altogether. RM example. Now I don't have anything. Good. Let me see where I am. Am I in my project folder? It's not even want to let me do PWD. That's what you pay when you're working on Windows using the Windows subsystem for Linux. So I'm going to have to get out of this terminal so I can issue PWD. Oh, the whole thing went away. So I need a new terminal here. Let's get it. And I have PowerShell here. Does PWD work in PowerShell? Yes, it works. So I am in the right location. As you can see, my package 1, 2, 3. Okay. So again, I'm going to go back to Julia. And I'm going to go to the package manager. And because again, I use Julia all the time, it already activated this environment using activate. Let me show you what this terminal did for me. I'm going to again get out with activate. Okay. And now I'm going to get my little environment. That's what you would do in the Python ecosystem with pip, was it VM, like Python-m VM, and the name of the environment and so on. If I want my current project or folder to be the environment, I just issue the following command. Activate, period, like so. And I get my package 1, 2, 3 already. If I didn't have a project.toml file here, activate would have created it for me. Okay, but because I already had it, it just loaded that metadata into the scope of the environment here. Okay, now let's check the status. Do we have example? In my case, that's the function that I need to use my fact function. So let's check with status. We go here, and it says that I have an empty project. No wonder why it's not finding do math, right? So let's add that dependency to that project, to the environment. So let's do add example. And let's check the status. And now we have example, right? So to recap, we are in the project where we generated the project structure with the SRC folder, with the module file within, and the project.toml file. And at the base of this project, we issue the activate that period command, okay? Afterwards, we added that dependency example, which we're using in our code. Okay? And now let's try this again. Let me zoom out a little bit so we can see everything. And I'm going to run this code again over here. Okay, I can copy the whole thing and paste it right here and run it. Seems like it might work. I mean, we don't know. This is exactly what we had last time. So now let's call fact. Let's see, do we have fact? It says fact not defined. For those who have used Julia before, what's going on? I need to bring the module, my package 123, into the scope with the using keyword. So I can do using my package 123. And I got some problem here. It says, I have a partially installed environment. Try PKG instantiate. Let's try that. From the package manager. If you got that error, you should do that. If you manage to run it, then fantastic. Did anyone manage to run it? Yes, we have some yeses already. Yep. Yes. Oh, I have my package here. My package. My environment, yeah, because I ended up changing the name. See, that's a problem when you copy paste stuff. Dangerous. So would it work if I use my package? Probably. Let's see, using my package. It didn't work either. So I have to update this. 1, 2, 3. Let me get in. Now let's do it again. So copy this. There we go. Can I do using my package 1, 2, 3? Still have some problems here. Maybe I need to do this anyway. This is instantiate. Let's try it. Now again. Nope, have a problem. So when things don't work, what do? We close the whole thing, open it again. Let's try that. Go back to Julia. I'm activating my project. I can go to the package manager. Yeah, see that? I don't remember if I saved this though. Let's see, save. Get out, back in.
How do you save?
You can press Command S or go File, Save. Okay. And again, let's try this. Check my environment. Good. And do it using my package 1, 2, 3. And now it works. That almost always works. This trick of starting from scratch. Are you getting this kind of feedback? No? Okay, we can do some debugging later. But that was the problem. If we go back and check our environment with ST, I see example. And now if I do fact, I get the fact. Okay. So testing the code is critical, right? Sometimes it takes a few iterations before we can finally get it, right? So now that we have, in theory, right, we have tested this code and we know it works for us, we can share it now with the world. And we have the structure that we need. We just need to tell people about it so they can start using it, okay? So let me go back to my notes. So here's the testing and the debugging that we did, and then the success. Now, before we share this code with other people, I have a few suggestions. Sometimes we have written a ton of code, and there's a lot of personality, of our own personality in the code, right? In the text. It is recommended to format your code so it complies to specific styles, so that other people are not distracted by our choices when we were actually writing the code. Right? So for this, I am suggesting you add suggesting you add a .julia formatter.toml file to your project and adding this text style equals blue, which is supported by the Julia extension within VS Code. So if you have this file, let's do that real quick. Go to the file manager. Let's add a file here. And I don't want to add it within source. I want to add it out here. New file. Let's call it .julia formatter.toml. And over here, we can add style equals blue and save it. If we go back to our file and add something strange to our file, like leading space, and save it, we can actually format the whole file very easily. So if we right click and do format document, the VS Code Julia extension is going to format it for us right away. Okay, so that's good to have before we share code with other people. Right? And also, although this file is useful for telling the Julia extension what to do about formatting Julia files, we don't really want to have to include that in the package that we're going to be sharing with others. So to do that, we add a .getignore file. So if you have VS Code, we can go here to the source control panel. And do a couple of things. First of all, we need to initialize a repo, right? So click on that. You see, now we're using Git, and we're not really writing anything on the command. So now we have a repository. Hopefully everybody knows what a Git repository is. And here we have the new files we added to the project. We have Julia formatter.toml. We don't want that to be included, to be committed to the repo. So we right click and add to getignore here. So let's do that. And look at what happened. We no longer see Julia formatter.toml. Instead, we see getignore. And if we click on this file, we see that Julia formatter.toml was added. So now Git is no longer tracking that file anymore. Okay? Now we're ready to commit our changes. And to do so, we need to add or stage the file. So to do that, we can go here to changes, right click and say stage all changes. Now all the changes have been staged, and now we can add a commit message. Let's do that. First commit. And click on commit. And here we have something. Do I want to save? I guess I have some changes that I haven't saved. Right? So let's save all and commit. Sure. You see how nice it is to use tooling already? And we're done. We have committed our changes. Now we just need to share this with other people, right? Do you see this big blue button right here on the left? It says publish branch. Let's click on that. If you already authenticated your GitHub credentials within VS Code, you're going to get this prompt. Do you want to push or get these files to your GitHub account as a private repository or as a public repository? Well, I'm going to click on public because I want other people to see this. Click on that. I get some feedback down here saying that it's uploading files. VS Code's doing that for me. And now I get more feedback saying successfully published the repository to GitHub. Really? Let's take a look. And I see my GitHub account, and I see the package, and indeed I see the project right here. Is this easy to install? Let's verify it. I'm going to copy this link. Know that this is not in a registry somewhere, right? But we can still share it very easily. I copied this link, and I'm going to go to my base Julia installation. Let's see. See, I'm in base Julia here. status. I have no packages. I want to add this brand new package we just created. So I'm going to do add, paste the link, enter. We see similar feedback as we had before. Check the status. I see my package 1 to 3 pointing to this link in my GitHub account. Can we get the fact function? Let's see. Go to Julia, import it with using my package 1 to 3. Didn't complain. This is good, looking very good. Am I gonna get the irrefutable fact that 2 plus 5 is 7? What do you think? And there we go. We have successfully written reusable Julia code that's easy to distribute, easy to get, and it just works for everyone who's gonna grab this code and use it, regardless of their computer, regardless of their setup. It'll just work every time. This is the end of the workshop. Do we have any questions, either here or on Zoom? Let's see, do we have any questions on Zoom? No questions, I guess. Question over here?
So we can now share the repo via like, the Git URL. Can you talk about the process of getting package that you author on the general Julia registry so that people can just say, add on my package 1, 2, 3 rather than the URL?
Absolutely, yes. To get a package in the Julia registry, it's they have some requirements. So, for example, if you have dependencies, you need to specifically indicate compatibility data for the different versions that your package would be useful or usable if some versions are not available. For example, you may have other dependencies that require a specific version of the dependencies that you're using for your own code. So in those cases, the package manager may resolve those conflicts by going to a dependency of that common package that works for your and all the other dependencies that you have. So that's something that needs to be added to the project.toml file. There's a section about compatibility. They also require that the package name be unique for obvious reasons, and some other requirements, but the process is really simple. You just add a comment in your repo, like in a commit or an issue, and then Julia, they have a bot that takes care of the rest of the process for you. That's pretty much it. You set it up a little bit, and then they take care of it for you. They really work really hard to make sure that people have a very friendly experience using Julia. Yeah. Any other questions? Do we have anything in the chat here? Seems like we don't. So thank you, everybody. This was a very fun workshop.
My stuff is let's see.
Source. And now let's check your environment. So I'll go back.
Yeah.
I mean, I'm already.
Copy all of that. Yeah, and now we do the my package. If you guys have somewhere, then that's all.
That would be like. Stay.
That's what I'm going to make. It's just like long thing. Let's get out.
All right, do that.
You can do.
Yeah,
Oh, okay, get it, you should get it, you can use
Today.
controls.
I had it in it's for people were submitting the check. And I was like, oh. I think it's very good. Like, well, you get to know everyone. Everyone's
Good, now, run it.
go through new.
Oh, do working package.
And then.
Exit
I
package.
don't think it was against there.
The you thing.
And letting everyone else know.
It seems like
I think
my package is already in there. Can you try typing my package?
Answer.
It seems like it's a. Can you do my package to do it better?
See, that's what I'm too. Are the dates?
And remove the phone.
Yeah, that's what it was. It was a bunch of folks from like, there's some masters and also. And I think.
Yeah.
Yeah. That was right. Stream of like 5.
So you have it in school.
Yeah, so that wasn't happening.
That's why this goes.
That's good.
Okay,
It is a good number.
so now I'm trying to commit it.
Right, so you have to stage changes first. So you can right click on stage the changes. Oh, you have, you already staged. So just.
Thanks,
edit
Carlos.
the message. Yeah,
Thank you, Carla.
sure. And click on commit.
There.
Yeah, because you had an open file. Make sure you give your username. You have to configure it. That's
Well,
why
it's like a piece in every
you have to
box.
configure. So let's do,
Literally one piece in every box.
you open the door, you're gonna get some feedback.
I mean, there's no like.
No, there's not. And let's.
But it's like really funny. It feels like one
Yeah,
of those
right.
things where it's like, you're
If
not allowed
it's
to
a
laugh
big global
because
user
of out of
email,
politeness.
Yeah,
Yeah.
that's it with your phone. And then get config global username.
Knowing the,
In the regular,
how do I get back?
with command, oh, you can try, simple,
Oh, yeah.
see that. Okay, that would be username, your GitHub. user.
No, as in like getting.
Alright.
Do we get a weird one?
Yeah, your user.
I haven't used
You have a-
it. I mean, I
You have
have,
an account?
yeah, I have an account, I just don't,
Your
I
number?
haven't used it.
You gotta be using it.
Oh, that's true. You'll devour it. I'm not taking it, so I'm just hoping. Some. Oh, take the salad, free reign. Take as much as you want.
I didn't send it.
Uh,
Yeah, the engagements, so.
We're done. So. Yeah.
Username is.
I had class today.
all that.
That's what I'm realizing my third.
Hey.
Guess who we're in days out.
You have to take you, right? And let's chat, right?
So the grant,
Yeah.
the take the unity plan, user even for idea.
Oh,
You
yeah.
You have to,
Right.
let's convert that,
Yeah, I could do that.
user that name and say.
Like, oh, I am.
Oh, you do that.
Space, yeah. Good, and then do the same with user that email and then. Now let's try. Fail to say the content of the file is new. Let's make sure that we have. Yeah. Yeah, just click on overwrite, right? Yeah, I guess the files are committed. Let's double check that. Try here to git log. To git command. Yeah, it was good. Now you can try push into your remote repository. Yeah, just click on publish branch. So you have to sign in to get out within this. Yeah.
Yeah, I did watch it. Okay, so we said.
Yeah, yeah. Either, yeah, a public.
Yeah, it's yeah.
And then you can check that it's in your GitHub account. And that's why we're here. Can you, how did you do that? Let's see. What did that later?
This.
Yeah. Now go to just base tool here. Yeah, you can use a terminal outside of this. Yeah, maybe that one. Yeah, we can use this one. So check this the scope first.
I do.
The package manager.
Okay.
You're in the base tool. Do you have this my package? What we not do is ST.
No, I don't.
Right. Let's add. We can add and then place that one. No, let's use it. You're using my package. You can use tab completions.
Oh, yeah.
And now let's see if you have packets. Try running the packets.
Okay, perfect. Thank you. Thank you.
You're welcome.
Do I have to, can I just get out of everything?
Yeah, it's okay. Everything's in your remote repository.
Yeah.
So whatever happens to your computer, you still have.
Okay, so, and which is why people like,
Exactly.
because you can, because it's still, because you know, it's your, you have to log in, it's still
Exactly.
private. But like, but I don't need to like carry around a laptop or. If I,
Maybe some other computer, get the code right away.
okay,
And if you need help with Julia and stuff,
I mean,
programming, later
yeah.
at CCB, you can we have a community. It's on Slack.
Oh, yeah, I have.
Yeah, you can make consultations to VDD staff and other members of the broad community.
Yeah, I mean, I'm getting pretty good at using Julia itself. It's more the GitHub experience because it's just that, I mean, I had like a computer science minor. So there was one class where I had to use like all these, not Git, but like stuff like it, but that was like a while ago. And then all the other classes, they didn't really care.
Yeah.
So for me, it was just easy, you know, because it's so much nicer experiment on like Jupyter Notebook. I really haven't had like a good chance. But
Yeah,
now
this
that
is
I'm,
something that you acquire, you know, by just using it a little bit.
yeah.
But this is the standard. You kind of like keep
Yeah,
trying to changes.
Yeah.
So, this is the way.
Yeah. No, I know GitHub. It's just I haven't had a chance. I find especially the like not programming languages, but setting things up like this because there's so many like little computer things that if you don't have someone, it's extremely. Do you get like I find like once you get that coding operational, learning how to program is not that hard. At least I didn't find it that hard. Like I remember, like I read like. I skipped the first semester in computer science because I read like the whole C++ book, but like I couldn't figure out how to compile the code.
Right.
So I like walked in the second semester, like I wrote it all, and he was like, "How you compile?" I'm like, "Let's compile." I'm like, "How do I compile?" I don't know.
It is true.
And he was like, I actually ended up getting like an A, but he was like, I was so scared that moment.
But yeah, this is something that you incorporate, you know, slowly. Takes a little bit.
Thank you.
You're welcome.
So you'll do this every Thursday?
Yes, free pizza, you know,